Hey there, my name's Eli White. I'm a software engineering manager on the React Native team at Facebook. Today I'm going to talk about a lot of the JavaScript changes that we're making in React Native. We've talked about our architecture changes a lot. We've talked about it at previous React Native EU, where we're rewriting the UI layer of React Native. We've talked about JSI and how we're working with new interactions with our JavaScript engine and the improvements and performance benefits we can get there. We've also talked about, last year, Emily gave a talk about the new architecture and the way that we're initializing React Native and some of the performance improvements that we're able to make there as well. But we haven't talked about JavaScript. All of our conversations have been about the changes under the hood, the kind of improvements that will come to React Native from the architecture. But now I want to talk a little bit more about what this means for all of you from the product side, the JavaScript that you write. How does this actually affect the JavaScript? So today we're going to be talking about a couple of things. I will start with a little bit about the architecture improvements we're doing on the JavaScript side, how we're using code generation to solve a common pain point, and some of the removals and deprecations that are coming as part of the upgrade to the new React Native architecture. So to start with all of this, I want to kind of share how components render in React Native. The JavaScript that you write creates views on the screen, but how does that process actually work? So the JavaScript that you write, it might be a view with props and styles, and the view that actually gets rendered to the screen might be this blue square. So we write this JavaScript and we get this box on the screen. But there's a bunch of different steps that happen between those. So let's go through that. Right before that box is rendered on the screen, we have these methods. On Android, these are Java prop setters that take the value of a property and apply that value with the native Android APIs to the view. Something to notice here is that the JavaScript that you wrote said background color blue, but the Java method receives an integer. So something somewhere is translating between this blue and this int. The JavaScript does some processing and it sends some information to Java. And this information is a payload with these different properties in it. And something you'll see here is that the background color is an int. It's the int that is sent to that Java prop setter. And in JavaScript, we still have this blue. Another thing to notice is that in JavaScript, we have this invalid prop, but that does not show up in the payload. So something somehow, somewhere, knows to convert blue to this int and knows to remove invalid prop. And this thing that knows how to do it is called a view config. The view config is a description of the component, of all of the different properties that it receives, all of the different valid attributes, and how to process them. So you'll see here for accessibility, height, and width, that it says it has the value of true. True means whatever you set in JavaScript, just pass that along into native. Don't change it at all. Background color, however, has this object with a process key. And process color, this module, is a function that receives any of the kinds of values of colors that you write in JavaScript, from blue to RGBs to hex values. It takes any of those values and returns a number, and that's the number that gets sent to native. So React knows when you render this view to process all of this information that you wrote in JavaScript with the view config to create this payload. And then the payload is sent to native. It calls each Java prop setter with each method, which then gives us the view on the screen. So I want to go back a couple steps to this view config. We know that these view configs convert from what you wrote in JavaScript to what native expects. But where do these view configs come from? You probably haven't seen them before. So these view configs, even though we at render time are using them to send the information we need to native, we actually create these view configs and calculate them at startup. So at startup, we actually look at these annotations on all of the different properties for these components. And we create this description of the component that is calculated with reflection from the Android code. And we send that description to JavaScript, which then processes this description into the view config that React then uses to know how to convert from view. So one of the problems with view configs is that calculating this is really slow, and we do it at startup. And the problem here is that we are doing it at startup, and we do it every single time. So every time you start the app, even though nothing has changed, we recalculate the same thing. If we go through it, for every component at startup, we have to load that component off of disk. We have to use reflection to read all of the props, and reflection is pretty slow on its own. We build up this object description, and then we serialize this object description, send it to JavaScript, which then converts it to view configs, registers it with React, so that React knows what to do in the future. One of the problems with this is that it means that the more components that you have registered in the app, the slower your startup is. And this is really sad because you might have a ton of components in your app that you never use at startup, and they will slow down your app. These also don't change ever. So what if we could just kind of cache these view configs by putting it into a file in our bundle? That seems like it might solve some problems, but it brings us another problem. And it's that a different platform might have a different definition of the props for the same component. So a view config is the representation of props for a given component on a specific platform. If we look at the different ways that we might write these props on these different platforms, you'll see that we kind of have different ways of defining them that are similar but kind of different. And these are the sources of truth that we use to create these view configs, that we know how to process these components. But because we read these and calculate these from the native code, that means that these can be different. If you've ever run into a problem where a component property behaves differently on one platform than the other, or takes a different value on one platform than the other, this is why. It's because our source of truth is in native. But these aren't the only sources of truth we have for what definition a component takes. We also have our JavaScript types in Flow or in TypeScript. And these need to be consistent as well. And you might have API definitions with Markdown or some documentation about what the component type takes. All of these need to stay in sync, but nothing is keeping them in sync right now. And so you can run into a ton of different problems with as you're writing your applications. So that's problem number 2, is that you have multiple sources of truth. They're both calculated at startup, and they can be different. But the view configs are really only needed for JavaScript to know what the props are. They aren't needed for native or anything else. It's just JavaScript. So the idea of saving it to a file was a pretty good one, but the problem is, how do we keep it in sync with native? So we're going to solve these problems, and we're going to change our view configs from being calculated at startup to no longer have any runtime calculation at all. And we're going to get rid of multiple sources of truth and have a single source of truth in JavaScript. And the way that we're going to do this is with automated code generation. We call it codegen. You may have heard of the codegen project as part of our new architecture. That's what we're going to talk about. So codegen in general is a process of taking some source inputs and generating some artifacts. For us, our source could be any different kind of JavaScript typings that we want. Because we use Flow at Facebook and nobody else does, we knew that we had to support both Flow and TypeScript. We then process those JavaScript types into a shared schema that is consistent between TypeScript and Flow. And then we process that schema and we generate a bunch of code in different places. So this lets us generate those Java methods instead of reading those Java methods. Our type definitions for a component might look like this. And you'll notice that there's some things that are slightly different from what you are used to with types. You'll see this like with default definition. And the reason there is that we used to have these things read from the native code. We used to understand what the default value was from that annotation in native. But since we're defining these in JavaScript, we have to have some of these kind of things defined in JavaScript. So this schema then generates, in Java world, it generates a native interface that our component would then implement. And it can also generate our view config in JavaScript. And that view config will now be part of the bundle at build time instead of having to be processed and calculated at runtime. And one of the great things about this is that it makes sure that our types in JavaScript are consistent throughout the whole system. So there's no more reflection or any calculation at startup. As I said, we're doing this all at build time. We have a single source of truth in JavaScript that ensures that our whole system is consistent and we have the same types all the way through. Now, this process that we've talked about for components isn't just for components. We actually have the same system for native modules. Native modules are exactly the same thing. Native modules are a class with a bunch of methods on them. So we're also defining the type for those methods in JavaScript and generating the native interface to make sure that our types are consistent. So it's the same thing for both components and native modules. One of the other benefits of this is that it also provides a bunch of performance opportunities. We now are defining the input and the output, and we can use codegen to change the entire system throughout. We can improve performance by moving some of the codegen to C, making some really good performance optimizations there. We can hide all of that from you and other engineers creating third-party components and modules, because the codegen means that you only have to write the input and you get out these native interfaces. We can change how we communicate through those on our own. What this means is that if you use typed JavaScripts, you will no longer have cross-language errors. This whole class of problems that we've had in React Native for years will completely go away. We will know if you define something in JavaScript with a certain type, if your build passes, then the native code expects the same types. And this isn't just going to be available for core, this is also just part of the experience of writing components and native modules in the new React Native architecture. So we will provide this for everybody. So we're talking about the new JavaScript architecture today. We've talked about the improvement to startup performance with view configs. We've talked about how we're using code generation. Now I want to talk about what we're doing for removals of old features and some of the things that we're deprecating. This isn't everything that we're deprecating, but it kind of gives you, the goals here is to give you a sense of the things that are important to us and how we're kind of thinking about it and the changes that we're making. Of course, as we get closer, we'll have documentation for all of this. There'll be guides, there'll be everything. And everything that we're talking about here are very subtle features. They're very uncommon, rare, used only for edge cases and often only in library code. It's very likely if you've been writing React Native apps, you've never used these, this will never affect you. And our goal here is to make sure that the JavaScript code that you write can work in the new architecture with as few changes as possible. We have thousands of components at Facebook and hundreds of engineers working every day in these code bases. We can't just make a change and require like everything to change. We have to do things incrementally and have to keep code working as is. So with those disclaimers out of the way, let's talk about it. And I want to first start with the UI manager. The UI manager is how JavaScript communicates with native. In a lot of ways, this is what you think of as the bridge. This is where we serialize how JavaScript communicates with native. This is where we serialize information from JavaScript to native, and we make a bunch of assumptions in this communication path that can lead to race conditions and kind of gives us a cap on our performance. The UI manager is not used by Fabric. We've solved these problems and have a new path, and we've talked about that in some of our previous talks. The UI manager was never meant to be used directly by product code. It was meant to be hidden inside of the implementation of React Native. However, some of this information and methods have kind of leaked out into product code. In areas where we haven't defined really good APIs, we found product code has kind of reached in and used the UI manager directly. So the UI manager is going to be deprecated. Like direct calls to the UI manager from product code is going to be deprecated in the next few months as we kind of get closer to our new architecture, and we want to help you be able to migrate off of these calls. So I want to give you an example of what a call to the UI manager from product code might look like. So this is some code calling measure on the UI manager and trying to measure the size of a view relative to a scroll view. And you'll see a bunch of these UI manager calls in these kind of places, and there's a lot of problems with these, and we'll kind of get into that in a second. One of the other examples is view manager commands. This is another method on UI manager. View manager commands are kind of like methods on a component. So if you've ever used like scroll to or flash scroll indicators, or if you have a map and you want to call move to region to zoom the map to a different location, these are imperative methods on a component. One of the problems with dispatch view manager command and these UI manager measure calls in general is that they're completely untyped. So for view manager commands, the arguments to this method are in this array as that last argument, the region and duration. And there's nothing ensuring that those are type safe and consistent with map component or move to region. You can put anything there that you want. So there's for measure, there's an API that's existed for a couple of years, and most code uses this. And so now we're just making sure that when you need to measure something that you don't call the UI manager directly. Instead, you call ref.measure and use the much nicer, simpler API. So this ref.measure API has existed for a long time, and we're just getting rid of the uncommonly used path. For commands, we are introducing a new API for being able to call commands that solves the problems of type safety, is being able to call those methods directly on the component, passing a ref to that component and the arguments. And this is much nicer. Both of these APIs for both measure and move to region are much nicer. But looking at this commands argument, you might think, well, what is this commands thing? What do I have to write here to get this? And the answer is you don't have to write anything. The magic is codegen. So let's go back and look at our example schema, the JavaScript we write to define what the component looks like. We mentioned this already. You have these types, you define the props, you might specify defaults for these different values. But these schemas aren't just for props. We can also define the commands in our schema as well. And so in the schema, as you write your commands, you write these methods that are type safe, and you export this constant commands. So the codegen actually uses this spec and replaces that commands constant in a Babel transform with the method that you have and the implementation for that to work and call to native. This spec also generates the native interface for this command, again ensuring that the type that you write in JavaScript is consistent between the types that your code is being type checked against to the native code that is being compiled against. So let's go back to our original code, our UI manager calls and the new APIs as well. One of the things you'll see in these UI manager calls is all of these different calls to findNodeHandle. And findNodeHandle is problematic on its own. So bonus, we're going to be talking about findNodeHandle. findNodeHandle is a function that takes a component ref and returns a ID, a unique identifier to a native component. So if we take this view hierarchy, you'll see that we have this RN tester app. And if we call findNodeHandle with a ref to this RN tester app, the ID that we get back is the identifier for this RCT view, for the native component underneath. So the new way of calling ref.measure is a lot cleaner. But there's a gotcha. And the gotcha is that the old way used findNodeHandle, which means that we were able to call this with any JavaScript component, with a ref to any JavaScript component, and it would find the nearest native component to call measure on. Well, with the new API, you have to call, when you call ref.measure, the original UI manager with findNodeHandle, this ref could be any component ref, and ref.measure has to be only a native component ref. So it seems like the old way was actually nicer, but it wasn't. And let me explain why. And the answer is that findNodeHandle kind of sucks. Let's take a look at an example for why that is. So let's say we have a root component and a myProduct component. And root is attaching a ref, getting that ref back, and measuring that product component. So this is what it would look like with UI Manager Measure and findNodeHandle. And things can kind of get a little bit funky. Let's say that my product expands and it becomes my complex product. And it's in another file and it has tons of code in it, worked on by tons of people, but we're still measuring it. You might think that this is measuring just the outer view, but it's not actually that simple. What is this measuring? Let's take a deeper look. Let's say that my product, the view that it's rendering is the content of the product page. And then someone comes along and they say, okay, I want to update the product page. I want to add a header to that component page. So they wrap it in another view, they add the header, and now when root is calling measure on my product, they're measuring the size of both the header and the content. Okay, maybe that's what you wanted. Maybe you wanted to understand the size of the whole page. But originally you were just measuring the content. But okay, this is fine. And then some engineer comes along a couple months later and they say, we have this view that is just wrapping these two elements. We don't need that anymore. There's this new thing called React Fragment. So they modify that to get rid of the extra view. Well, what they didn't realize is that root was measuring the nearest view. And that was the wrapper view. So now that root is measuring my product with findNodeHandle, the ID that it's getting back is the ID for the header component, which is not the ID for the content component, which is what they probably originally expected. So this is pretty kind of scary. Your product code can change with what seems like a simple refactor. And this is why findNodeHandle is bad, because it requires this global understanding about all the different parts of your code base. And one of the things with React is we really want to enable you to only have to think about the specific part of your code base that you're working in. This means that it's easily broken by refactoring. If you move things around, if you reorder things, if you kind of change nested views to fragments, all of this can break. It's also slow. findNodeHandle has to traverse the React tree from the ref that you passed it to the nearest identifier. And being able to traverse this tree is slow, but we also have to maintain this tree in memory, which means that the code size for React and the memory size of tracking this whole hierarchy is extra just to support findNodeHandle. So findNodeHandle is going to be deprecated in React Native soon. We still have a couple of use cases for findNodeHandle that we don't have new APIs for, and we'll make sure that all of those exist before findNodeHandle is deprecated. But if you see findNodeHandle calls, you might want to kind of think about whether there's a better way to do it. There often is. findNodeHandle is actually already deprecated in React DOM. It's not called findNodeHandle in React DOM, it's called findDOMNode, but it's deprecated for the same reason. And they recommend on the React website that instead of using findDOMNode, that you use ref forwarding. So let's go back to our example and take a look at what ref forwarding means. So instead of calling instead of calling UI manager measure on findNodeHandle with my product, we want to attach a ref. The ref that we get from my product is a ref to a JavaScript component. We want to get the ref to the content view. So React forward ref lets us wrap our component and attach that ref directly to the content view. So now when you attach a ref to my product, you're getting the ref to content and not a ref to the JavaScript view. And now that component ref in root is actually a native component ref, we no longer need to call findNodeHandle. We already have the ID for the native view, which means that we don't need to call UI manager measure either. We can just call component ref.measure. This is much cleaner, much nicer to work with. So forward ref is great, and it solves a lot of the problems that we have with findNodeHandle. It gives us an explicit API and enables local reasoning. You can understand the code that you're changing. You can see that your component is attaching a ref to a certain component, and as you move things around, you can keep that being connected. Forward ref can also be type checked, so you know that when you attach a ref to my product, that you're actually getting back a native view ref. So all of the core components in 0.62 use forward ref, which means that when you use view or text input or anything like that, and you attach a ref to them, you're actually getting a ref to the native component. So these are all of some of the the built-in React Native core components. And you'll see that those are all marked with forward ref. When you attach a ref to them, you get the ref to the native view that they render. So as I mentioned, findNodeHandle is going to be deprecated fairly soon in the next couple of months, and we'll help you with more documentation about all the different use cases and how to migrate off. But this has been kind of a taste of the most common things that we've seen with findNodeHandle. So in the new JavaScript architecture, we've talked about how we're improving startup performance by no longer recalculating view configs, how we have a single source of truth that's JavaScript for our components and our modules. We're using automated code generation to take that single source of truth in JavaScript and generate the native code that uses the same types, giving us end-to-end type safety throughout the whole system. We've also talked about how we're removing the UI manager and we're deprecating both access to UI manager because Fabric doesn't use it, and how we're giving some of the uncommon calls with findNodeHandle and UI manager proper supported APIs. We've also talked about how we're removing findNodeHandle to help you enable to have encapsulation and use Fabric compatible APIs. That's all I've got. Thank you so much. My name's Eli White. You can find me on Twitter at Eli_White. Thank you.